Hi everyone, this is our final year project, which is Enterprise Retrieval Augmented Generation System. It's basically a RAG system. So our team consists of two members, myself, Sanjay, and Santosh. So our domain is basically a full stack with AI powered domain. So let's move on to the problem statement of this project. So problem statement goes like this. So organizations manage large volumes of digital documents that are critical for operations and decision making. However, retrieving accurate and contextual relevant information from these repositories is often inefficient and unreliable. Traditional search systems lack semantic understanding, while large language models, when used independently, suffer from hallucinations, outdated knowledge, and lack of source traceability. These limitations reduce trust and hinder the adaptation of AI in enterprise decision support environments. Therefore, there is a need for a scalable and reliable system that integrates information retrieval with the language generation to deliver evidence-grounded and explainable responses. As said here, in government or any places, there'll be lots and lots of data chunked or loaded in RDB. They may be structured, semi-structured, or unstructured. Most of the keyword based matching systems are work or is efficient for only structured documents, but our system works for all the three categories and efficiently search and fetch the data. Let's move on to the architecture diagram. So this is the architecture diagram of our rack system. So it comprises of four layers, mainly a UI API layer, rack component, and knowledge storage layer. So UI is basically a React UI, which is just a user interface to interact with the backend. And the API layers we have used here is a fast API, so everything is written in Python. So the API gateway handles the requests, authentication session, and logging. The RAG component layer and the knowledge storage area are the key major layers in our RAG component system. So this RAG component has the document ingestion module, orchestrator module, embedding module, and response generation module. The RAG orchestrator, basically an orchestrator is a master that splits the task into, or ingest the task into the components explicitly. So now knowledge storage layer has the monitoring and logging, knowledge storage module, and retrieval, context construction, and response generation as final. So so the users basically injects the data though, so that data is converted into chunks, and these chunks are converted into vector modules and embeddings, and they are stored in a DB. So when some other user wants to access this document or wants some text from any of the document in the DB, they can just query, and these queries are then converted into vector embeddings, and these vector embeddings are matched against the DBs where the documents are converted into vector as well. So these matches is done, and if the match is found, then the information is retrieved. So let us show you the working and running of the application, and we'll explain how this matching is done and with what algorithm. Over to Santosh.
So yeah, as you see, this is our application, which is basically an enterprise RAG assistant. So this is the home page of our application, where you can see the description of our project. And as you can see, there is a sign up as well as login. And when you are giving the sign up page, you are seeing both the user create account as well as the admin sign of creation. This is the login page. I will first show you the user login. As you can see, I have a As you can see, the password is actually incorrect. We can also reset our password. So basically, and the forget password link has been sent to the mail successfully. So we can also reset the password. So the reset link has been sent successfully, and this is the password reset request. And once we click the link, see we can set the new password. And the password has been updated to sign page. And once the user login, again the landing page will be shown. And this is the upload document page where the users can choose the file and upload it. And basically these documents are broken down into the chunks and has been stored in the MongoDB. So this is the uploaded document by the user. So far he has uploaded these many documents. And this is the chat in interface where we are going to search related to the documents. And as I say, there is a two mode in our project. One is the enhanced understanding mode and the normal mode. First we will see how the normal mode works. So I have given the question explain purchase order, and as I have uploaded the document related to the purchase order, and we find that the text matches the relation to the purchase order has been displayed. Basically the matching has been done using best match 25, where we have also used the sentence transformer model in order to broke down the text and we have also used the TF-IDF vectorizer. So basically both these matches will be compared, and where the top 25, I mean best match 25 function will retrieve the top 25 matches. So these are the texts. So now we will see in the enhanced understanding mode. So yeah, this is the enhanced understanding mode where we are going to get some more responses what the document says, as well as we have also integrated the LLM explanation, and it shows about what is the purchase order and what are the process involved in the purchase order too. You can see that, and we have the source evidence of it, and you can also download this document as the reference. You can also see that this is the downloaded document where you can see the project. Then one more thing that differentiates our application is that compared to the other RAG, we can also extract the images that are present in the document too. Say for example, I have, as a user, I have uploaded the RAG related document where I'm going to retrieve the RAG architecture image now. So as you can see, the RAG architecture image has been generated, and you are seeing the document references. All these documents are same only, but as it is uploaded by multiple users, it is showing the top matches. You can also download this image too. You could see this. Okay. So now we are going to see about the admin side of things. So yeah, again you can see the login page. So again for the admin 2, you are going to see the landing page, and the admin also can upload their documents too. And these are the so far the uploaded documents across all the users who are present here. Let's see the number of documents. So again, the admin also can ask this question related to the documents, and these are the users who have registered in our application. You could see the role-based access control has been there, and this is the admin analytics part where we can see the number of queries per day. It shows how much the queries has been done in a particular day, and these are the top users, and we can see this based on the number of queries they are given in the application. And this is the intent breakdown, which basically says which basically categorize the questions, and we can see the definition, summary, procedure, and these are the most asked questions which are regularly being asked, and this is the most used documents across the user, and this is the performance per day, which also leads to our latency. And this is moreover our enterprise RAG assistant application. Yeah, thank you.